If you look at a cross-section of the small intestine, on the inside, it's going to have a kind of curvy, wavy appearance here. You have all these little finger-like projections. Each one of these little finger-like projections, like that would be one, and there, like that. Each one of these little finger-like projections comes up, and that's known as a villi, or excuse me, a villus. Plural would be villi. The whole point when you have villi anywhere is to increase surface area here. So you have all these little curves, and that increases all your surface area, so you can absorb more food stuff, and you just have more surface area for food absorption. Then if you look at the mucosal cells on the villi, each one of these mucosal cells has little villi sticking out on top of them as well, and these are known as microvilli. So microvilli are finger-like projections of the individual mucosal cells. The villi are these finger-like projections that are on the interior surface and open up into the lumen of the small intestine. And again, both of these structures are designed to increase surface area for primarily absorption. So you're going to have a lot of absorption going on in the small intestine. This is your large intestine right here. This is your small intestine. Your small intestine is actually divided up into three parts. You have the first part that comes right off where the stomach leads into it. That is known as the duodenum, and that's a small section. It's only about 10 inches long. The whole small intestine itself, which is all curled up in here, is about 20 feet long. But the duodenum is very short, but it's very important. You're going to have all of the ducts from your liver and your gallbladder and also your pancreas. So there's your liver, and then your pancreas is right here. Let me show you the pancreas on this model. Here's the liver here. Let's get rid of all this. So if we pull the liver out, you've got the stomach here, and then there's the pancreas here. So all of the contents from the pancreas and the liver on this guy are going to dump into this first area right here of the duodenum. And let's stop just and talk a little bit about the system of ducts. You've got your your liver. That's actually this guy's liver that sits right here, and the liver has 4 lobes. Those lobes are not listed in your lab guide, but you need to know them. You have this large lobe over here on the right side, which is known as the right lobe of the liver. The right lobe of the liver, and then you have this smaller lobe on the anterior surface, which is known as the left lobe of the liver. If you flip it up like this, so see how I'm turning it so you'll get your bearings right here, then you have this kind of, it looks like a rectangle right here next to the gallbladder, and this rectangular lobe right here is known as the quadrate lobe. Now think quad is 4, so it has nice 4 even sides there. They're not totally even, but that's the quadrate lobe. And then back up here, you have what's known as the caudate lobe, C-A-U-D-A-T-E. And caudate, it comes from the word caudal, which means tail, so that kind of looks like a little tail here. So you've got your right lobe, your left lobe, your quadrate lobe, and then the caudate lobe. So those are your 4 main lobes of the liver. Then, of course, on the inferior and posterior side of the surface of the liver, you've got the gallbladder. On this liver right here, there's your gallbladder that they've cut it open here. Remember, the gallbladder is nothing more than a storage area for bile, those bile salts, and help emulsify fats. And so you can't digest fats unless you have that bile coming from your liver. But your gallbladder you can live without because your liver is still producing bile. The gallbladder is simply a storage area for the bile. So you don't have quite as much bile when you get your gallbladder removed, but you can survive without it. This guy probably shows the better duct system. But basically, coming down from your gallbladder, you've got one duct right there. John, are you zoomed in on that? Okay. That duct right there is known as the cystic duct. So the gallbladder drains into the cystic duct. Okay? Then you have ducts from the liver lobes that come together. So you've got the right hepatic duct. Remember, hepatic means liver. And then the left hepatic duct. And so the right and left hepatic duct are going to join together to form this short little area here known as the common hepatic duct. And then the common hepatic duct is going to merge with this cystic duct from the gallbladder, and that forms what we call the common bile duct. Okay, so you've got the gallbladder right here that drains into the cystic duct. Then you've got the right hepatic duct, the left hepatic duct, and they join together to form the common hepatic duct. Then the common hepatic duct joins with the cystic duct to form the common bile duct. The common bile duct then will come down here and join up with the main duct, this central duct from the pancreas. That's known as your central pancreatic duct. Over here on this model, you can see it a little bit differently. That would be your central pancreatic duct right there. So that whole organ right there is your pancreas. That's the central duct of the pancreas. But notice that that duct is going to dump into the small intestine, and also this common bile duct is going to dump into the small intestine. And you can see an opening right here. Can you see that, John? Where they dump in. That's known as the hepatopancreatic sphincter that opens it up, or the hepatopancreatic ampulla, where they both meet and come together to dump into this duodenal area of the small intestine. Let me run through it on a different liver just so you'll see it from a different point of view. Again, we've got the right lobe, left lobe, the quadrate lobe, the caudate lobe. Then you have the gallbladder, which drains into the cystic duct. Then you have a right hepatic duct, which is going to this right lobe of the liver. You have a left hepatic duct, which is going to the left lobe of the liver. They come together to form a common hepatic duct. The common hepatic duct and the cystic duct join together to form the common bile duct. The common bile duct then will meet over here with the central duct of the pancreas and dump into the duodenum at the hepatopancreatic sphincter, this little opening right there. Okay, so that's the liver. So let's go back to the small intestines. Notice they're just kind of wadded up in a ball here and kind of encased in the large intestine. You can't distinguish from the exterior surface which is duodenum, ileum, and jejunum. You know duodenum is going to be the first part of the small intestine, but you have to look microscopically at the changes on the inner surface to know which is what on the inside. So we're just going to say this is mostly ileum and jejunum, and there's your duodenum up there. So the jejunum is the middle part of the small intestine, and then the ileum is going to be the last part. So if you take this off and open it up, and you see this last part here, which is the ileum, that's going to be dumping into the small intestine right here. It's what is known as the ileocecal valve. Now it's called the ileocecal because of the ileum, and then this little area right here is known as the cecum. So that's that first part of the large intestine, makes this little pouch here, and that's what we call the cecum. So this spot right here is your ileocecal valve, where the small intestine dumps into the large intestine. Coming off of the cecum, you're going to have this little small part here. I'm going to pull this out so I can show you. That's your appendix. Now remember, these are both filled with a lot of bacteria, so if this gets inflamed and it ruptures, you're going to blow bacteria all throughout your peritoneal cavity, and you can die from that. The bacteria can cause sepsis, and it's not a good thing. So if you have lower right quadrant pain, people are generally going to try to investigate to see if your appendix seems inflamed, because you want to get that out before it bursts. And of course, you can live without that. It has a lot of immunological tissue in it, but you can just cut it off and be done with it. All right, so coming up from your cecum and your appendix, you're going to go into what's known as the ascending large intestine, or ascending colon. I'm going to put this liver back on this model over here so that you can see it makes a curve right here. Well, it's curving right next to the liver, so we're going to call this first curve the hepatic flexure. So there on this model here, this would be your hepatic flexure, which is right next to where the liver is. So you go up the ascending colon, then you have this hepatic flexure, and then the colon comes across, just straight across like this. Well, that's a transverse section right there. So this is going to be your transverse colon. This would be the transverse colon in this model. And then it's going to turn and go down. Well, as it turns and goes down here, notice it's next to the spleen right here. So that turn right there is going to be called your splenic flexure. So that little curve right there is your splenic flexure. And then the colon starts going down. So then we're going to call that the descending colon. So you have your cecum and appendix, ascending colon, hepatic flexure, transverse colon, splenic flexure, and then the descending colon. Then if you pull it out, you can look on the back side, and you're going to see that it kind of makes this curly S here. Well, this next curve, so if we're coming down the descending colon, that curve right there is going to be known as your sigmoid curve or sigmoid flexure. And that's because this little S-shaped part of the colon right here, well, not starting right there, that is going to be called your sigmoid colon. And then finally, that leads down into this straight part of the colon right here, which we call the rectum. And then from the rectum, that's going to lead out into the exterior of your body through an opening called the anus. So the anus has two sphincter muscles on it. You've got an external and an internal sphincter muscle. So if this is the rectum coming down like this, you've got longitudinal smooth muscle here that surrounds it, which is known as the internal anal sphincter, and it's smooth muscle, so you don't control that. Then you have a circular muscle that surrounds it, which is skeletal muscle, which you do control, and that's your external anal sphincter. So that's how you decide when things are going to come out and when they're not. So those sphincter muscles are right at the anus, which is at the base of the rectum, so that's that opening to the exterior. Okay. Now, all of these organs in your abdominal cavity, which runs from the base of the diaphragm down here, are covered with a connective tissue covering known as peritoneum. So this whole cavity here is also known as the peritoneal cavity. So you can have visceral peritoneum or parietal peritoneum. Visceral means it covers an organ. So the membrane that surrounds this organ here or this organ here, that's going to be known as visceral peritoneum. And then the membrane that surrounds the cavity itself is going to be known as parietal peritoneum. So you have parietal and visceral peritoneum, and both of those peritoneal membranes come together to form the mesentery. And then, of course, you've got your mesentery that hangs down in curtains, which we call the greater and lesser omentum.